Hello, good evening, good afternoon, good morning, wherever you are joining us from for this AI Masterclass. My name is Laura Masters Stonehouse. I'm the Manager of Student Experience here at Fourth Rev. Now, I work very closely on our data analytics and digital marketing programs and work very closely with our success managers, career coaches, and expert facilitators to ensure all learners' experience is fantastic from the very beginning all the way through the 4 courses and then out the other side into our kind of completer territory. Now, this evening's masterclass is really exciting for us. We welcome back a number of our current learners who are currently on the programme, actively pursuing the Career Accelerator. And we're also very pleased to invite a number of prospective learners considering joining our programme later this summer or potentially later this year. So tonight, I'm very, very pleased to welcome back our AI specialist, Jessie Schmidt, for another fantastic installment on our AI Masterclass series. Must just confirm, of course, anyone who is a current learner and also prospective learners, it isn't necessary for you to have reviewed the earlier sessions in the masterclass before tonight's show. But without further ado, I will hand over to Jessie and ask her to begin the show. Thank you.
Hi, yeah, thank you, Laura. Super awesome to see all of the international people. I'm joining from San Francisco, you might guess by my background. But we're going to talk about AI and biology today. So let's just get into it. I'm going to share my screen. Just 1 second. Okay. All right. Is that good? Okay. So welcome. Thank you all for joining. Hope you're having a beautiful Tuesday. And I wanted to, since we're talking about biology today, find it a little bit fitting to do a little body activation if you're on the other side of the world. Maybe it's nighttime for you and you've been sitting all day. So don't worry, it'll be very quick, very nice. So I just want you to sit up very straight in your chair and then put your arms on your shoulders like this. And then we're going to go back and forth. And then when you go to the left, you're going to inhale, and to the right, you're going to exhale. And then just do that 10 times along with me. And on the 10th time, reach up all the way to the ceiling. Inhale. And then release. That's just so good for loosening the upper back. Putting a little bit of energy in too. And yeah, I've been really looking forward to this session because human biometric data is the topic that I interface most with when it comes to the intersection of data and AI. And there's so much to cover. It's really, really exciting future for applying AI to solving all sorts of different kinds of challenges and opportunities in healthcare, and ultimately learning more about the world and our species and how we can function better within it. So what we're going to talk about today are some of the very most cutting edge applications from my personal experience being heavily involved in both the intersection of AI and human health, being in the Bay Area biosphere. I did my bachelor's in neuroscience and spent several years doing research on mental health and psychopharmacology, and also did my master's of international business before moving into the AI space, working with startups, both as a developer for prototypes using low-code tools and as a strategist. And I've been working more recently on advancing how we design our AI second brain systems to make our first brain better. And what I hope to do today is to give you sort of a sense of what's coming in this big space of AI and biology and data and what's possible. So let's cover the agenda. How are you all feeling? If you could give one word to describe how you're feeling, it could be related to the class or what you're anticipating or not, or just life. Feel free to type it in the chat. Awesome. So today we're focusing on bio data. If you were here and you remember, that's awesome. Feeling fantastic, excited, intrigued. Okay. The last couple of classes, we went through different industries. So we did finance and then social media marketing, which are both very relevant and important. But when it comes to future impact, I think AI and biology combined will absolutely change the world in ways that we never knew or saw coming. So what we'll cover will include how the combination of AI, data, and biology will revolutionize healthcare through democratization of data. We'll talk about what different leaders in the field are saying, like the CEO of Nvidia and Eric Schmidt, former CEO of Google. I'll share some personal insights and anecdotes, just to add more context in a whirlwind of different events that are been crazy in AI and biology over the past month. SynBioBeta, the largest biotech conference, BrainMind in New York, and right now Deep Tech Week is happening, and all of these are very heavily themed on the intersection of AI and biology. We'll play with a DNA language model. We'll also work with Claude this time because there's been some cool updates with Claude, and I definitely want you all to get acquainted with that. Yeah, and then we'll cover some other weird concepts and like self-driving labs and organoids and protein design. And then especially when you have things interfacing with biology, I think in healthcare data, ethics is super important in AI in general, but I think like even more so when we add the biodata layer. So we're gonna talk about ethics and what is AI ethics and how do we think about it. And then at the end, I'll leave hopefully some time to cover any questions. There's be a lot to cover in today's session. And you all can feel free to type anything you want in the chat. If you have questions, I can answer some while I'm going, but I might leave some for the end. So if you see there's like a chat box and then there's a Q&A box. So if you actually want to put your questions in the Q&A box, and then throughout the session, if you see one that you like, you can upvote it and then we can go from there. I saw US man said, I'm interested in the finance session. Where do I sign up for that? I believe there was a recording if you have access to that. Yeah, but it'll be very broad sweeping today, and I will be inviting you all for some discussion. That sound good? Okay. So first, I wanted to show you a quick 1-minute clip. You might have heard a lot about Nvidia recently. It's been in the news a lot as like a big AI company now. Here's the CEO, Jensen Huang, giving some context on
where do I think the next amazing revolution is going to come, and this is going to be flat out one of the biggest ones ever. And so I told you I was going to tell you, and I'm going to tell you. And there's no question that digital biology is going to be it. For the very first time in our history, in human history, Biology has the opportunity to be engineering, not science. When something becomes engineering, not science, it becomes less sporadic and exponentially improving. It can compound on the benefits of the previous years. And every company's contribution, every researcher's contributions compound on each other. For the very first time, we know how to represent biology, understand the language of biology. We can represent the language of chemistry. It's never happened before. And I'm very proud to say that Nvidia is, at the center of all of that. And we've made it possible for some of this breakthrough to happen. And now we're going to have incredible tools that brings the world of biology, which is very chaotic and random, or not random, but very chaotic and constantly changing and very diverse and complex, obviously, and bring it into the world of computer science. And that is going to be profound. And so if you happen to love this intersection, I think it's going to be rich with opportunities. It's going to be a giant industry.
All right. Cool. Yeah. And this is what he covered basically. Intersection of AI and biology will be a transformative force. I'm wondering right now, actually, who's in the biospace or interested in the biospace versus any other area? Like, what's your industry of interest? If you want to type that, and just interested to know where y'all are coming from. Okay, cool. Sustainability, health tech, policymaking, public health. Katarina said labs, economics. Yeah. How AI affects the international stage. Yeah, really interesting. I'm interested in that too. So Jensen Huang covered this topic of digital biology. What does he mean by that? What is digital biology exactly? I asked Claude to help me make a mind map. This is what it came up with, and the topics has AI-driven research, computational biology, synbio, precision medicine, digital twins, high performance and quantum computing, biodata integrations, AI sensing, evolutionary algorithms, and protein design and ethics. We're going to touch on a lot of these today. And yeah, really at the core, digital biology harnesses the power of data, algorithms, and computational simulations to understand, predict, and manipulate biological systems in unprecedented ways. Do you want to find out how to make a mind map of your own using Claude? Who all uses Claude versus other LLMs? This is also good context for me. Yeah, there's a lot of really cool things you can do with Claude, and I'm actually moving away from ChatGPT, at least for now. We're going to talk about ethics in this class, and there's been some ethical concerns around OpenAI. And the Claude 3.5 is also crazy capabilities. Okay, you all are saying, please show us. All right, so I already had this set up. Okay, so what you're gonna do is go to claude.ai, and I can put this in the chat. If you don't have an account, just go ahead and make one. And I'll follow along with you. So go ahead to that link and then just log into Claude. And when you get to the front page here, make sure that it's on Claude 3.5. All right, and now here's the prompt you're gonna use, and you can put any topic in the brackets, or just, delete the brackets. So does anyone have a suggestion for what I should make a map of as we follow along on this? All right, I'm gonna pick Doctor Who. And it will output this lovely markdown format. And then all you have to do is just copy that, and then you'll go to this link that lets you convert markdown to mind maps. And just delete the standard one that's in there, and then, oops. Okay. So cool. I've never actually watched this, but it looks like we got a mind map of the characters and the elements. And then you can even download this as an interactive HTML and open it up and zoom. And what's really cool with this method is I've taken like research papers. You can upload whatever sources you want, and you can be like, make a mind map out of this paper, this thing that I'm studying or trying to understand. And I think mind maps are more representative of how we store information in the brain, so it's super cool. All right, did everyone get that and good to move on? How's that? Cool. Okay, so yeah, now that we're talking about healthcare, we're going to jump into more the medicine side of AI and biometric data. So if we're able to harness this data in all of these unprecedented ways in biology, surely it has to have a huge impact on healthcare, and it does. Here are just a few like basic examples of how AI can help us, but on a deeper level, data can become almost anything. When we have sensors attached to ourselves or our environment, monitoring whatever we want from the environment. So let's say around like health and pollutants in the environment, or our own biometric data, we can treat that as language almost, and like use that as language in training new language models using the same basic transformer architecture that the LLMs like ChatGPT and Claude are based off. So I'm going to make this more personal first and talk to you about your own data, and then expand outwards from there. Who here wears and loves wearing their health wearables? I use an Apple Watch to track my fitness. Yeah, we have things like Apple Watches or Oura Rings, Whoops. Soon we'll be seeing maybe BCI, more pupil tracking, when we have smart glasses and things like that. There's a lot of like really weird dystopian ones too. So someone told me recently that their friend was developing like a metal pill that you swallow, and then it can measure all these biomarkers in your blood in real time. So many new ways emerging on collecting data on our own health. And it's both scary and exciting because it ties into the question of ethics. Who will get access to that? data and what will it be used for? If you have everything being reported from you, are you okay with marketing companies having access to this data? On one hand, it's really awesome to just like have that moment of synchronicity where you didn't even know you needed this product and then it was marketed to you at just the right time, and then like you got it before you even know you needed it. But at the same time, it can be used to hook your brain in, and maybe in a very like money-oriented world, your best interests are not really in mind with these kinds of systems. So how do we redesign the data systems so that we're focusing on the humans? So just in medicine and healthcare, we're collecting all this data. What do we do with it all? It can do all these things, and improving accuracy in diagnosis, detecting diseases early, personalizing medicine to yourself and your biology, and accelerating drug discovery. We're going to talk more about the science aspects of this. But I think the most important aspect of data when it comes to your own health data is to take ownership of that. And that's where really a big impact of AI in healthcare will be democratizing healthcare and access to high quality care. And by empowering individuals with access to their own health information, we can drive more personalized, proactive care and really unlock the potential of precision medicine. And all of that comes from advancements in biowearables, patient-generated data, and secure data privacy and data sharing are really key for this and paving the way for a more patient-centric healthcare system, I would say. I listened to Sarah Gottfried on the Huberman Lab, and she said this line that I really liked. That was the future of healthcare is democratization of data. You already have people uploading their blood test results and things like that to ChatGPT and getting diagnoses that match what their doctors say, and obviously AI outperforming doctors on medical exams. So how do we balance the role of that and not let it take over the humans? And as someone who once was really interested in becoming a doctor, I'm super thrilled about AI's like threat, you could say, to medicine, because what AI does extremely well is the algorithms. And a lot of Western, especially medicine, is the algorithms. If this symptom, then prescribe that treatment or diagnose that. But what it can't do is the human element of healing, which is very important. And like if you know about psychoneuroimmunology and how the patient-doctor relationship is actually more important to the outcome than anything that they did like or prescribed themselves. So what I see is eventually we'll have a platform where we can integrate all of our biometric data, all of our test results, and provide virtually zero-cost healthcare to everyone. Yeah, Nathaniel, that's a good question. So how is quality built into these systems? All of it's based on the training data. So that's why I think it's really interesting, because big AI companies are generating synthetic data now at this point to train their models, because the common consensus is that more data improves the accuracy of the models. But in that sense, like if you're putting in more and more AI generated data, how do you know what's accurate to begin with? But so I think there will be a overturn of data hygiene when it comes to the AI models that we choose to interact with. I think that smaller local models will actually increase in popularity because you can more fine-tune and control what it actually learns from. But in the end, like, we can also look at the stats with this, and maybe it's not 100% accurate, but if it's as good or better than an actual doctor, you could ask the question, like, if it has a higher rate of prescribing or of diagnosing correctly, then wouldn't it be unethical to not use that if we can be more accurate? And yeah, just one example of this, actually, my partner is working on is TCM, and this is something that I see also is there's a lot of different modalities in healing besides just the Western model that our insurance covers. And so being able to access a lot more information around how would your thing be treated in, say, like Ayurveda or herbalism or TCM can provide a lot of interesting context and broaden the scope of what medicine is. And in the end, I really think it comes down to owning your data. But that begs the question, what is your data? What kind of data do you collect on yourself? What kind of data what are you interested to know about yourselves? So I'm going to ask another question. What data do you collect on yourselves? We talked about smart wearables. Does anyone have like a daily journal where you log your workouts or you keep track of different things like your mood? Okay, sleep tracking. Yeah, what are the things that you like to keep track of and gain some insight about yourself? Yeah, calorie intake, heart rate. Okay, location, interesting. And what benefits do you gain from tracking this data? How does it improve your life at all? Yeah, blood glucose levels. Yeah, I also track a lot of these things. So Naeem said, keeps me motivated. Yeah, I think on some level, it holds you accountable, right? It creates transparency to have the log of what you did, of seeing your own data, keeping journal of your thoughts and feelings. This is intangible and not measurable, right? Well, I'd say it's definitely measurable in various ways. So it's a personal AI system could use NLP to gain insights on your emotional state around certain subjects or people, and maybe provide insight to deeper layers of your life. Yeah, what AI does really well also is uncovering patterns. So just imagine now you can have more and more aspects of your life tracked and patterns uncovered and optimized to learn how to live better. Would you want that? Imagine we'll all have the ability. Yeah, that's an interesting point Sujit brought up. How data ownership, biological especially, could become a currency of sorts in the future. And there is need for data. Absolutely. I also think not just your biological data, but your thoughts. So we will be able to have personal AIs with all of our notes and like our knowledge and things that we are interested in and write about. And I think for very smart, high profile people, their second brain will be monetized as APIs, and they can sort of like rent out their own second brain. Actually, that segues very perfectly into the next slide. The concept of the second brain. So all of the information that composes our second brain it's not just text data, but it's everything. I took a course called Building a Second Brain, and it was all about building an actionable information system for yourself. And now AI is, for me, becoming a natural extension of that. And the process as we progress will be, I think, learning how to mold these systems to extend our own cognitive capabilities. Of course, that's why we, like, in the end, have our smartphones and things like that. We're perpetually modifying ourselves more for intelligence. Because in life, the first most important asset we have to train is our first brain, and then the second is our second brain, because the second brain actually can help us train the first one by helping us create systems and hold us accountable and create more transparency to our behavior and how it matches with our actual goals. So the second brain is not necessarily just a singular note-taking app, although the picture on the right is what I consider to be my second brain. That's a graph of currently like a couple thousand notes in my Obsidian, which I'm a big fan of that app. But it's really just the collection of where you store all of your data on your devices. And if we can build biometric data into these second brains, then we can get adaptive AI systems that learn based on our emotions, which right now I would say is the missing component with LLMs and how we interact with them. So kind of swerving more into AI and hardcore biosciences, the reason that all this has been advancing so much is we have so much more data. And so we've been able to train models. I told you, yeah, there's so many different ways that AI can be applied to biology that have not even been dreamt yet. And another is in the areas of bioengineering. So I went to SynBio Beta, which is, I've said, the biggest global SynBio conference last month. A lot of intersection of AI helping us engineer biology to develop new foods or microbes, terraforming Mars, making genetically modified like lab-grown meat, as well as, yeah, brain, mind, and deep tech, which are going on right now. And we've found, yeah, Lena asked, what software did you use to create that network? So it's Obsidian. The app is called Obsidian, and it is my favorite note-taking app. I highly recommend it. You can start simple, though. It can get kind of complicated, but it stores everything in just plain text markdown files on your computer, which was my biggest concern with using things like Notion, because I actually got locked out of my Notion account for a few weeks, and I didn't have access to my notes. Obsidian, they're on your laptop forever. Anyways, yeah, AI has proven its success in protein language modeling. Genomics is the next challenge. So yeah, something interesting, if you've heard of AlphaFold, it's been a big thing recently. There was a yearly competition where different research teams would try to predict a protein's shape from the order of its amino acids. And suddenly, you can see there's a big jump in 2018 with AlphaFold, and then again in 2020 with AlphaFold 2. Before that, none of the models could really get above like 40, score of 40. But if you were there for the first class, we talked about transformers in the paper called Attention is All You Need that came out in 2017. And so after that in 2018, AlphaFold actually leveraged that and kind of shifted it to make their own transformer called triangular multiplicative attention. So similar to the underlying architecture of Claude and ChatGPT, but for proteins. And this was super cool. Okay, is the video playing? This was just my interaction with Claude. I'll show you this and then we'll get to try a little bit something similar to this. So I gave it this paper. I asked it to create an infographic. So I was able to create like an okay infographic. Could definitely be improved with more prompting. And then I asked it, I was just wanting to see, can it create an interactive web app? It said that it couldn't, but then it was able to code something and then display it that I was able to interact with this text box and enter a protein sequence. Unfortunately, it didn't output anything from there, but this was just released like last week, a few days ago. So super exciting the way that this is going. And actually, if you, okay, we'll come back to Claude in a little bit. I'll just show you first the DNA foundation model. So this was the ARC Institute was someone at this conference that I was at, and they created the first DNA foundation language model, which is pretty cool. You can use it to generate DNA. Do I have the link for it? Let me see. So Evo is the first DNA language model, which was created by the ARC Institute, which is based here in the Bay at Stanford, I believe. And they basically trained a language model, but using DNA sequences instead of language, or instead of human text language. And yeah, I thought it was something that shows like where the capabilities are going. So if you all just wanted to try it out really quick, you could click that link, and then on the side, you can see what model it's using. I'll just keep it as the base. And then actually, I might switch it. I'm going to do Meta Llama 3, 70 billion parameters. And then I'll say create a DNA sequence, 400 base pairs. Okay, so it gave me this randomly generated DNA sequence, and what we're aiming to get to is to just basically be able to generate CRISPR fragments and things like that, and then test it in real time how it will respond in the cells. And kind of on the same note, self-driving labs and AI in research. So this was an awesome article actually last summer by Eric Schmidt, the former CEO of Google, titled, "This is how AI will transform the way science gets done." He talks about how automated laboratories use AI to conduct experiments with minimal human intervention. and basically sift through vast amounts of research to generate new hypotheses. And it says in this quote here, if we play our cards right, we can build a future where AI-powered tools will both save us from mindless and time-consuming labor and also lead us to creative inventions and discoveries and encouraging breakthroughs that would otherwise take decades. And this is how AI can help with that. It can ingest large amounts of data. So you can use tools at your disposal very easily to just feed, say, Claude a research paper and ask it for the summaries or ask it for the top insights you want to gather from it, or make infographics or different tools to study analysis to identify different patterns and insights, and knowledge synthesis ultimately to generate new hypotheses and research directions. This is an example of that. So this is a scientist that I really like a lot named Michael Levin. His work focuses on cellular communication via bioelectricity. And in this paper, he applied generative AI to hypothesis generation in science. And so basically what they found in his lab is that a lot of the concepts in bioelectricity translate to similar terms in neuroscience and vice versa. So they trained GPT-4 just by prompting to translate neuroscience papers to change the relevant words to developmental bioelectricity. And then they had actual scientists rate the translations. And then they used it to grade abstracts, and you can see the prompt that they used and the response. And just to keep in mind, an application like this is very much a creative exploration. So you can't take the output that it's generating to be fact whatsoever. We've talked about hallucinations in previous sessions. You can't trust everything that LLMs put out, but we can treat the output as sort of virtual papers or virtual hypotheses to give us more insights and expand our imagination around what we can actually test in real life. But what was interesting from this paper is that they asked ChatGPT, after they had given it all this knowledge on all these papers, to develop a new hypothesis, and then they tested it using bioinformatics, and they found a new finding, which was a genetic overlap in the genes used for cognition in the brain and those used for development of the embryo, which was actually a very interesting finding. Yeah, and I also, just to quickly touch on this, with my experience, one of the things that I did in psychopharmacology research was we would watch videos of rats with a stopwatch and stop and start when they would start doing a certain behavior that we wanted to score. And yeah, this was just a few years ago, but it took literally forever just to score like short 10-minute videos from manually doing it, and then we would write it in. But now all of that can very easily be automated. And so you can see how as the volume of research increases, the capabilities of the researchers also increase. And then just to touch on a more specialized area, which I'm interested in, is kind of extending on that, neuromodulation and organoids. So this first little graphic was a picture or a study from last February, I believe, called Organoid Intelligence, the New Frontier in Biocomputing and Intelligence in a Dish. And then after that was published, a lot of conferences came around it. Different countries started wanting to invest in like organoid intelligence in their defense programs. Australia is investing very heavily in it. They've taught these organoids to play Pong. And then you can see a couple more recent articles AI made from living human brains actually was able to perform speech recognition. And recently there's a bioprocessor using 16 different human brain organoids for 1 million times less power consumption than a digital chip. Ultimately, the benefit of biology is that it's gone through billions of years of evolution, so it is very efficient. And so that's why we're looking more and more to biological systems, and potentially might end up seeing biology integrated with our technology in the future. And then I actually wanted to go back to Claude for a minute, because yeah, I wanted to make sure you all are set up to do this type of capabilities like I showed you. So yeah, if you all want to follow along with me and just go back to your Claude. So you have to enable the ability to run code. So what you do is go over to the sidebar and click on feature preview. And then you'll see artifacts, and you want to make sure that artifacts is checked on. And then I just did this other artifact literally right before class. I just wanted to show you. All I said was generate the HTML of a solar system GIF, or GIF, however you pronounce that. And it produced this beautifully interactive little GIF. And I've been trying this with a lot of different things, and it's actually been able to make like web apps and basic websites and pretty much anything. You could code games with it. The capabilities are really crazy, best I've seen for code generation for any AI so far. Okay. Now, is anyone trying that themselves? Is anyone trying to make their own things? Yeah, if there's something cool that you created that you want to share, I'm interested in hearing that. There's so much to explore, and I would say that's the biggest thing with this space, is just keep a really exploratory mind. Everything's changing so fast, and just stay curious, because if you're putting in 5 minutes, 10 minutes a day interacting with new technology, you're already ahead of 95% of the world, probably 99%. Lastly, ethics. Ethics is obviously very huge. So there's people leaving companies over AI ethics. One of the interesting topics is who gets to determine what's ethical or not. And when we talk about ethics, we tend to, yeah, I can do a share of the slides. I believe, yeah, the recording will also be shared, but if you want the slides, I can send out a link to those too. When we talk about ethics, we tend to think of alignment. So that is it aligned with what's most beneficial for humans? And I think what this requires us to do is actually take a step back and say, well, what is beneficial for the humans? And I also see there's kind of two prongs of AI ethics and measuring alignment, which is the way the models are trained, potentially perpetuating implicit biases and things like that. It's something to worry about. And also the handling of your data. What does the company do with it? Do they sell it afterwards? And initially in the AI space, and so I've been to quite a few at this point, discussions. ASF has a lot of like salons around existential hope in the future for humanity and AI ethics and these kinds of things, where people just get in a room together and say what they think. Initially, I saw a lot of the conversation around what the models are trained on and what they're telling you. So identifying any bias, mitigating bias, ensuring fairness, regularly monitoring. I think we saw some of the models kind of overstep and really censor really hard around this. And that is also a benefit if you don't want to be censored to use a local model. And then we talked a lot about transparency and explainability. So interpretable models, so developing AI systems that have clear decision-making processes that you can understand, explainable AI, so techniques to make AI reasoning basically more understandable to humans, creating more transparency there, and establishing responsibility for AI-assisted decisions. And then when it comes to healthcare, especially, the data privacy is really big. So having secure methods for gathering patient information. Of course, we have all these protocols in place in places like the US. I don't know if HIPAA is in other countries or an international thing, and the rules are different in different places. But yeah, informed consent, data protection, and transparency on data usage. So like I said, AI would have to adhere to HIPAA compliance, which OpenAI does not, although I believe they're trying to get a HIPAA certification. And if your data goes into a large data set, to anonymize it and develop AI ethically throughout the entire life cycle. This is where I'm also very curious to hear your thoughts on, would you rather have only your own control over your own data, no one else can see it, or completely free data sharing where everyone's, say, health data is put into a large database that can be used to advance science or research and things like that? Yeah, security versus access. I guess it's a relatively newer conundrum we're having to face. Yeah, Hinal said I would be pro to sharing health data openly. I would also be pro to sharing it openly if I felt very secure in where the data was going and what it was being used for. Yeah, interesting. This was an interesting video. Okay, that's cool. In the UK, you already have control who can see your health data. They have to ask permission. That sounds nice, like a good setup. In this video, has like 20 views on YouTube. It was an Ignite talk that this guy gave, but I actually think he touched on a really interesting insight, which is what matters here is, how do we make sure we're making systems that align with the humans and don't eventually harm the humans? And he's arguing that as agents, as our AI becomes more agentive and makes decisions on its own, if it follows the laws of evolution, which I don't know, why wouldn't it? We may see some resistance, like how if you take an antibiotic, not all the bacteria is killed off, and then eventually that strain could proliferate. So if there was an agent that theoretically was counter to what a human wanted, such as shutting it off, and it persisted, it might be in the minority of like 1% of the agent population, but then from there it would increase. And this is a hypothetical dystopian reality a little bit. We don't know if that'll happen for sure, but we are giving these systems more and more control over our lives, our data, our computers. So how do we factor that in? Ultimately, a lot of the talk now that I've seen has been about is how can we connect AI to actual real human outcomes, real human emotions. And I actually have two different friends approaching this from different angles. So one is a machine learning researcher who's making this system where model AI systems can learn and gain rewards from the standpoint of love and positive attraction. And then another person that I know is trying to build in a fear of human suffering. So literally a fear of death for AI to understand that that would be a bad outcome. And I'm working on emotional understanding. So AI comprehending your own emotions in your second brain system based on biometrics such as HRV and voice. And what I think it comes down to in the end is, how do we use AI to improve our lives and our future as a species? I just realized we end in 1 minute, but I might run a couple minutes over. But if you want to hop off by then, I can stay a little bit after for questions as well. So this quote I really liked. What we need to make AI. Oh, sorry. We need to make AI not just who we are, but what we aspire to be, so it can lift us in that direction. And this is an article on Peter Eckersley, who unfortunately I never got to meet, but I hear a lot of really good things, and he did really groundbreaking work to encrypt the web. And then he died suddenly from cancer. But before he died, he established the AI Objectives Institute towards this goal, which I think is kind of the broader picture of how we think about this. So I wanted to ask you all, what is the most important problem to solve? And actually, I was going to do it in this poll, but if you want to just type it in the chat so that we can have more time. What do you think is the most important problem that you will use AI to solve? Global warming, health equity, aging, yeah. How to live on the moon, cool. Yeah, sending emails, that's important. Efficiency gains in climate CDR, global diplomacy. Yeah, treating cancer, having control over AI. Common diseases like diabetes, yeah. What's interesting is I'm focused on voice right now, how we gain insights about our emotional state from our voice and connect our thoughts to our second brain system. And diabetes, actually, someone has developed an AI algorithm to detect with 90% accuracy, just based on voice, whether someone has diabetes or not. Yeah, it's really wild. Food, balancing well-being and economic growth, health and environmental sustainability, using AI to create speech for the mute. Yeah, that's super interesting too. People are putting sensors on vocal cords so that you can kind of just imagine that you're talking and not even talk, but it'll pick up that and then it can turn it into actual language. Can we get access to the diabetes AI? I think they open sourced it, but I'm not exactly sure. I can try to find the article. If you Google AI for diabetes detection, you might be able to find the study. Yeah, mental health issues, loneliness in an aging population. That's how can access and distribution of these new health aids be accelerated safely? Yeah, that's a good question. Anyone have thoughts on that? I guess that leads me to the last slide. So just to close, we covered a lot. I hope some of that will get to sink in and you might have ideas around how to apply this in your own field or aspirations, or maybe work in the intersection of data and biology and AI. And in the next class, I want to dive deeper into our own AI and data systems, and also make it more of a career-based discussion. But if anyone has any requests that you would be interested to see, please feel free to share. And then I'm going to leave this open for Q&A for until like 12:10 my time, so the next 6 minutes, and I can answer a few questions. Janisa said, what are some examples of free biodata sources? There's so many. It depends on what you're interested in. So I would just ask Claude, honestly. I'm going to stop the recording. Cool. And does anyone have any questions or insights or things that were surprising? Zara asks, how is Claude potentially superior to other forms of AI like ChatGPT or Gemini or OpenAI? Yeah, they're always changing and they're always like trying to one up each other. And there's different ranking metrics that people will use around how good is it at coding, how good is it at empathy. Like there's so many different things that an AI could be good at. So I would say just try it for yourself and see how it feels and how you like interacting with it. Awesome, Ellis. Great to hear. As a project management lead, it's opened my mind to endless possibilities. Yeah. Yeah, Nathaniel said, when do you see biological AI become common usage? Well, I guess if I understand what you mean by biological AI, it is pretty broad, but yeah, I think that probably in the next 5 to 10 years, based on everything that's happening, we will see a biology boom similar to the internet boom of the 1990s. But something about biology is it works on slower timescales. So yeah, we do have to wait a little bit and we do have to kind of work at the pace of the organisms. So I don't think it will ever be at the speed of like programming physical software on silicone. . Yeah, Alexander said, any recommendations on wearables to use? Well, what do you want to track about yourself? I would say, for me personally, I like tracking my health. I like my Apple Watch a lot. And I've been wearing an always on AI necklace. Actually, it's over here. So this records me as a second brain throughout my day and has been super helpful. It's like a wearable version of Otter. And all sorts of ones are coming out. So we're definitely seeing a lot of advancements in hardware. Zara said, what do you mean by a second brain? Yeah. So I had a slide on this earlier, but basically what I mean is it's your whole information system that you store on your computer. So if you have like your notes app, that's a part of your second brain, and you use it to offload information and extend the capabilities of your first brain. So your phone itself is kind of a second brain. You can use it. You can look up any question that you have and get an answer really quickly. What I like to do is focus I kind of have a lot of philosophy around how I treat my second brain as a tool for productivity, really focusing it in on insights and what truly resonates, because there's so much information. But what's important is what you put your attention on, which are only a small few things. So what I'm trying to do is have that done autonomously so I can collect the information and then have the relevant pieces and follow-ups be told to me by my AI. So yeah, Alexander, this is an open source one. It's an open source necklace that I built and have been involved with the open source team to actually build like several hundred of these to ship to developers. And it's called Friend if you search Friend GitHub. And right now it's still very much developer focused, but you can get a pre-order for a future version. Yeah, we'll benefit veterinary field too, for sure. Okay, well, thank you so much, everyone. I hope you all have a wonderful evening. And I believe perhaps just to the people that are in the master's class or to everyone that a survey will be sent out. So if you want to fill that out, I'm curious what any of your insights are and all of that jazz.
All right. Thank you, Jessie. I'll just jump in there just before you close the session, just quickly to say a massive thank you to yourself for leading that great session this evening. I think it got everybody's brain ticking away, their first brain and their second brains ticking away and thinking of all sorts of scenarios and questions. So thank you very much. And just to clarify there, what Jessie said, yeah, for anyone who's a current learner on the data analytics program, we're doing some surveys as usual within the community, and also the recording of tonight's session will be available in the community very soon after. And then just for any of our prospective learners who've joined us for the session this evening, obviously been very welcome, and hopefully spotted some new names in the group chat there that we'll see coming into the program next week. Just a quick reminder for anyone still making that decision whether to join the program, orientation does begin on the 8th of July for cohort 3, absolutely still time to quickly get in the door and come and join the program. And very excitingly, for cohort 3, they will also have an AI masterclass series with Jessie running through the second half of this year. So great opportunity for you not just to catch up on the recordings of great sessions we've had in the past, but also being able to join live, because I imagine, Jessie, your content is changing probably every day as you prepare for these. So it will help you keep a kind of finger on the pulse with her. So we hope to see you soon. And thanks very much, everyone, for your time this evening.
Thank you, Laura. Thanks, everyone.
Thank you. Thanks, Jessie.